Good morning, students. For this week, we will be discussing the chapter on surface area and volume of solids. So sorry that happened. Volume of solids. I think it's volume of solids. Pardon me for that. Okay, let's start. So in the previous week, we were just looking at 2D shapes, right? Something like a figure is having length and breadth. Yes, but in real life, it's not possible always to have only sides, only length and breadth. So imagine if we have length and breadth only. That is an example of a floor, but at times we have even a room, right? So room is having how many dimensions to it? So it is having three dimensions, something like length, breadth and height. So I will start this class by saying a solid has three dimensions: length, breadth and height. Yes. Volume of a solid. So let us understand what is it. Volume of a solid is the measurement of the space occupied by a solid. Yes. Imagine a room. So if we want to fit in room, how much space that room is occupying, so that how much air is inside the room, then that is nothing but the volume of the room, right? So that is the concept of volume. And surface area of a solid. Surface area of a solid is the sum of the areas of the plane or curved surfaces. So example would be, suppose I want to paint the room entirely, even the floor I want to paint, even the rooms I want to paint, sorry, even the walls I want to paint, even the ceiling I want to paint. In that case, I should know the area of each and every side, right? So in simple words, I should know the area of the entire room. Yes. So here I'm taking one example of a cuboid whose length has been written as L, whose height has been given as H, and whose breadth is B. Okay. So let us start by saying cuboid. What is cuboid? A cuboid, a rectangle when given height becomes a cuboid. That means in this case it will be length, breadth and height. All of them will be numerically unequal. So length, breadth and height will have their own set of values. And also it has six rectangular plane surfaces called faces. Imagine a room. A room has six sides, right? Four walls, one floor and one ceiling. So example I'm here considering here is above a brick. Okay, surface area will be given as 2 into LB plus BH plus LH square unit. If you see here properly, these are nothing but we are just adding up the area of different rectangles. So first rectangle, if you see in the first face, is length into height, so that is LH. Other side it will be LB. So length into height, I'll have two faces like this. Even LB, I'll have two faces like that. So if I add, I should get LB plus BH plus BH plus LH plus LH. So when I add, I'll get 2LB plus 2BH plus 2LH. From that, I'm just taking out two common. So you'll get the final. So you'll get the final surface area. So let's go to the other topic, that is lateral surface area. So lateral surface area is nothing but if we consider only the area of four walls in a room, so that becomes the lateral surface area. So that means surface of area which we can see directly. So that is lateral surface area. So lateral surface area happens to be 2 into L plus B into H square units. Now this is also very easy to understand. If you see here, the side which is facing towards us is LH. Yes, so it will be LH plus again that side will also be LH. So LH plus LH is 2LH, and also this side, so it will be B into H. So BH plus BH will become 2B. BH plus BH will become 2BH. So 2 I can take out common, so 2 into L plus BH square units it will be there. Remember girls, all these formulas are directly derived from the areas of rectangle only. These are, although it looks some rocket science, but it's like it has been derived from your areas of rectangle only. Then volume equals to length into breadth into height cubic units. Remember, so L into B into H cubic units, and length of the diagonal will be under root L square plus B square. Was for rectangle, now it will become under root L square plus B square plus H square. This also can be easily memorized. Yes, but let me just iterate on this point. In case of volume, unit should be cubic units. Don't miss out on that. Length of the diagonal is the longest rod that can be placed inside the cuboid. That means if I have a room, so what will be the longest rod that I can place inside the room is the length of the diagonal. Yes. So let us go to the other one, that is cube. A square when given height becomes a cube. Yes, given height becomes cube. That means in this case length, breadth and height will have all numerically equal values. Yes. So in this case surface area will be 6a square. It's also very easy to remember. One side will be a square, but I'm having six sides like that. So a square plus 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 a square, six times will become 6a square. So this is why I'm writing 6a square units. Lateral surface area, also easy to remember. I told you we have to consider only the four sides. So it will become a square plus a square plus a square plus a square. That is 4a square. Okay. So volume is also given. So volume is again a into a into a. So that will become a cube units, because in case of your square it was a into a, here it will become a into a into a, that is a cube units. Again, length of the diagonal equals to root 3a units. If you remember, in the case of square it was root 2a, but here it becomes root 3a units. I hope you are clear with the concept of cube and cuboid. Here we are not doing anything new, we are just adding the extra dimension, that is height, to the squares and rectangles and getting our respective figures. I hope you are clear with every formula that we have discussed. So we'll be discussing the problems in the upcoming classes. Thank you. I take your leave.